A trunked radio system is a complex type of computer-controlled two-way radio system that allows sharing of relatively few radio frequency channels among a large group of users. Instead of assigning, for example, a radio channel to one particular organization at a time, users are instead assigned to a logical grouping, a talk group. When any user in that group wishes to converse with another user in the talk group, a vacant radio channel is found automatically by the system and the conversation takes place on that channel. Many unrelated conversations can occur on a channel, making use of the otherwise idle time between conversations. Each radio transceiver contains a microcomputer to control it. A control channel coordinates all the activity of the radios in the system. The control channel computer sends packets of data to enable one talk group to talk together, regardless of frequency. The primary purpose of this type of system is efficiency. Many people can carry many conversations over only a few distinct frequencies. Trunking is used by many government entities to provide two-way communication for fire departments, police and other municipal services, who all share spectrum allocated to a city, county, or other entity. Principles of operation. Control channels equals, in essence, a trunked radio system is a packet switching computer network. Users' radios send data packets to a computer, operating on a dedicated frequency called a control channel to request communication on a specific talk group. The controller sends a digital signal to all radios monitoring the talk group, instructing the radios to automatically switch to the frequency indicated by the system to monitor the transmission. After the user is done speaking, the user's radios return to monitoring the control channel for additional transmissions. This arrangement allows multiple groups of users to share a small set of actual radio frequencies without hearing each other's conversations. Trunked systems primarily conserve limited radio frequencies and also provide other advanced features to users. Talk groups equals, a talk group is an assigned group on a trunked radio system. Unlike a conventional radio which assigns users a certain frequency, a trunk system takes a number of frequencies allocated to the system. Then the control channel coordinates the system so talk groups can share these frequencies seamlessly. The purpose is to dramatically increase bandwidth. Many radios today treat talk groups as if they were frequencies, since they behave like such. For example, on a radio scanner it is very common to be able to assign talk groups into banks or lock them out, exactly like that of conventional frequencies. Fleet maps and IDs equals, in some agencies, groups are assigned in a fleet map. This was implemented to make it easier to assign group ID numbers. For example, EMS would be on a separate fleet than police. In those fleets are subfleets or the actual talk groups. This system is not as common as the typical trunking method, but they do exist. In some communities the ID corresponds to a location or agency. For example, it is common to see a 1 or 2 in front of a police group and another number in front of a fire group. Scanning equals, most scanners that can listen to trunked radio systems are able to scan and store individual talk groups just as if they were frequencies. The difference in this case is that the groups are assigned to a certain bank in which the trunked system is programmed. In other words, the talk groups are stored on the trunked bank. Comparison with telephone trunking equals, the concept of trunking is actually quite old, and is taken from telephone company technology and practice. Consider 2 telco central office exchanges, one in town A, and the other in adjacent town B. Each of these central offices has the theoretical capacity to handle 10,000 individual telephone numbers. How many telephone lines are required to interconnect towns A and B? If all 10,000 subscribers in A were to simultaneously call 10,000 subscribers in B, then 10,000 lines would be required between the two towns. However, the odds of that happening are remote. Telephone companies have well-proven formulas which predict the optimal number of trunk lines actually needed, under normal conditions, to interconnect 2 telephone exchanges, called the Alangby formula. This concept has simply been applied to radio user groups, to determine the optimal number of channels needed, under normal conditions, to accommodate given number of users. In the event of a widespread emergency such as a major earthquake, many more users than normal will attempt to access both the telephone and radio systems. In both cases, once the trunking capacity of the systems is fully used, all subsequent users will receive a busy signal. In our example of police dispatch, different talk groups are assigned different system priority levels, sometimes with preempt capability, attempting to ensure that communication between critical units is maintained. Differences from conventional two-way radio. Trunked radio systems differ from conventional radio systems in that a conventional radio system uses a dedicated channel for each individual group of users, while trunking radio systems use a pool of channels which are available for a great many different groups of users. For example, if police communications are configured in such a way that 12 conventional channels are required to permit citywide dispatch based upon geographical patrol areas, during periods of slow dispatch activity much of that channel capacity is idle. In a trunked system, the police units in a given geographical area are not assigned a dedicated channel, but instead are members of a talk group entitled to draw upon the common resources of a smaller pool of channels. Advantages of trunking. Trunked radio takes advantage of the probability that with any given number of user units, not everyone will need channel access at the same time, therefore fewer discrete radio channels are required. From another perspective, with a given number of radio channels, a much greater number of user groups can be accommodated. In the example of the police department, this additional capacity could then be used to assign individual talk groups to specialized investigative, traffic control, or special events groups which might otherwise not have the benefit of individual private communications. To the user, a trunking radio looks just like an ordinary radio. There is a channel switch for the user to select the channel that they want to use. In reality though, the channel switch is not switching frequencies as in a conventional radio, but when changed, it refers to an internal software program which causes a talk group affiliation to be transmitted on the control channel. This identifies the specific radio to the system controller as a member of a specific talk group, and that radio will then be included in any conversations involving that talk group. This also allows great flexibility in radio usage. The same radio model can be used for many different types of system users simply by changing the software programming in the radio itself. Since the talk groups are constantly transmitting on different frequencies, trunked radio systems makes it more difficult for a scanner listener without a programmed trunk tracking scanner to keep up with the conversation. In 1997, radio scanners compatible with trunked systems appeared on the market. One of the first companies to bring these devices to market, Uniden, trademarked the term trunk tracking on December 5, 1997. Types of trunked radio systems: TETRA, Open Sky System, APCO Project 16, APCO Project 25, Smart Trunk, Tetrapol, DPMR Mode 3, DMR Tier 3, NXDN, Kenwood Nexit Digital Trunked Radio, ICOM IDAS Digital Trunked Land Mobile Radio. Ericsson GE, EDACS Pro Voice, EDACS, GE Mark V. Hytera, Hypera DMR Tier 3 Trunking Pro, Hypera DMR Tier 3 Trunking Lite, AccessNet TIPTETRA Trunking System. Logic Trunked Radio, LTR Standard, LTR Passport, LTR Standard and Passport, LTR Multinet, LTR Net. Motorola, Type I Type 2, Type E Hybrid, Type 2 Smart Zone, Type 2 Smart Zone Omnilink, IDEN, Motorola Capacity Plus, Motorola Connect Plus, Motorola Harmony. TIRT, Tennessee, 9300 DMR Tier 3 System, Tennessee, 9400p25 System, TN13/5100 MPT1327 System. MPT1327. Notes: talk groups, scanning, and group calls are defined in Section 2, Needs Summary, Arizona Phase 2 Final Report, Statewide Radio Interoperability Needs Assessment, Macro Corporation and the State of Arizona, 2004, pages 16. The document Conventional and Trunked Radio Systems Comparison Report from the Department of Homeland Security analyzes and compares conventional, trunked, and hybrid LMR systems and provides high-level definitions of the architecture alternatives associated with each option. U.S. Patent and Trademark Office Registration Number 2,407,576, Serial Number 75,400,608, registered to Uniden America Corporation.